Okay, YouTube, this is a math problem video. I'm going to state a problem, and then if you want to work the problem yourself, you stop or pause the video until you've done it to your satisfaction or given up, perhaps, and then view the last and probably longer part of the video for the solution, or a solution in this case. Well, here we have a chessboard. Okay, you position a chessboard white on the right. That's as it would be in game of chess. And it's got all these squares, and these squares, one by one squares of which the chessboard is composed, have edges. The question is, what is the total number of one by one square edges of which this thing is composed? And in fact, I'm going to tell you right up front what the numerical answer is. The answer is there are precisely 144 one by one square edges of which this is composed. Your task, should you choose to accept it, is to come up with a neat way of counting up these small square edges that is not tedious and gives you the answer fairly quickly. And as a bonus, once you've done it in the case of this chessboard, which is an 8 by 8 grid, you can easily, with just a little more thinking, come up with a general formula for chessboards of any size, at least chessboards where the one edge, or any edge of the board that is an even number, such as a board that's 2 by 2, 4 by 4, 6 by 6, and so forth. Okay, pause or stop to work the problem yourself if you care to. Then we go on. Well, there's going to be probably one neat way of quickly counting up the edges in this here 8 by 8 grid, but this is a neat one at least. All right. The 8 by 8 has 64 squares. Half are black, 32 of them. And of course, these squares, one by one squares, have 4 sides each. So total black square edges is 32 times 4, 128. All we must do to get every one by one square that there is fill in white square edges on the perimeter. One side of the chessboard is length 8. Half this length is white. The perimeter is total length 4 by 8, which is 32. So just half the perimeter is white. That is to say, 32 divided by 2, 16. Us adding those two subtotals up, you're going to get, well, as you can see, 128 plus 16 is 144. There are other neat short ways of doing it, but I like this one. And particularly, this gives you a easy way of seeing a general formula, as I indicate in this here slide. Let E be an even number. How many edges are there in total in an E by E square grid? Well, color half the squares black, for example, or any color you please, really. That's half the squares. Each has 4 edges. 4 times e squared divided by 2. That's part of our subtotaling. The perimeter of the grid is 4 by e in length. Just half the squares along the perimeter aren't black. So add half the perimeter length, and that's our part B subtotal. So for our grand total number of edges in an E by E grid, it's going to be A plus B, 4 times E squared divided by 2, plus 4 times E divided by 2. A yet simpler form of that you can easily see is 2 times the quantity E squared plus E. Now, I'll just say to the astute problem worker that there are advantages and drawbacks to simplifying that. The advantage, of course, is that's a much shorter and simpler formula. In fact, you could also express that, we see, as 2 times E times the quantity E plus 1. But on the other hand, the drawback of simpler formula is that the simpler one often doesn't tell you how you got there. The unsimplified form really suggests how you got there. And the 2 subtotal pieces that make up the finished grand total of squares in a grid, assuming one side of the square grid is an even number. Till next time, this is ending that current math problem video.